Alrighty, hello everyone. Today I kind of wanted to show off how exactly the AI works in Super Smash Brothers Brawl slash Project Plus. Um, I wanted to show off my workflow and like give a little bit of history about how it came to be where it is today. All right, alrighty. So let's dive into it. So what used to happen is there was this program, AI script fed, that was developed by a modder named Bero. Now, Bero was a pioneer in the AI space alongside Dan Tarion, and they worked to develop this AI editing program. It used to use a JavaScript-based syntax. Well, most recently, he developed AI ScriptPad 2.0. ScriptPad 2.0. And this is what it looked like. We had like projects, solutions, scripts, and this is just kind of how it worked. Now I'm going to open one of the scripts real quick. This is just in Captain Falcon's Project Plus AI, and this is what it looked like. It had some basic code folding and a few other text editing features. This was before the days of Visual Studio Code, so this is actually very impressive for the time. Um, we got like reference for documentation and stuff, and a whole bunch of other useful features. Um, like for some auto completion and stuff, and that was all you had. This was all you had. So you might be wondering what are the drawbacks to using this. Well, as you can see, it's not super pretty. Stuff like called as, short outports, this stuff isn't syntax highlighted. It's just not a very good user experience overall, at least not compared to today. So today we have text editors like Visual Studio Code, which allow you to make some custom extensions. So the beautiful thing about AI Script Pad is this is just the front end. This is just what the user sees. What it also came with was the back end that actually compiles things in the form of a C# program. And I used that to create a command line tool that allows me to then interface with it through Node.js and a Visual Studio Code extension to allow me to do stuff like this and export data from the pack file. Going to just export it into this folder, sure, and we're going to select. And then it exported successfully. Great. All these files are new and exported straight from this pack file, which is where the AI actually resides. They reside in the motion etc. files, or the etc. files in the case of Project Plus, which split a bunch of the files for independent costume effects. Okay, so that's great and all, but how exactly do things work under the hood? Well, so every sort of command, it's a very command-based system. So we have commands, we have routines, we have requirements, which are like used in if statements for conditions and stuff. We have the sub actions for characters. We have a list of actions for characters. Actions. We have functions which give you various values. We have custom functions which were created by the PM dev team. We have this definition for like how the AI PD works. We have attacks, characters, etc. And all these go together to kind of like tell the game in the compiler how stuff goes together and how to ultimately execute things in game. So let me show you exactly how this AIPD file, like the AI flow in general, works. So the first thing that happens is we go to this AIPD file, and this contains things like dice roll information. And dice roll information is like if you want to randomly call one of the moves with attack dice roll, you can. These and these values, random chance values. And here's the where the other routines are called. So this is like this can be considered the main function, the main script. So whenever these conditions are met, it'll call edge recover. This is Ganondorf, by the way, base Ganondorf from Project Plus. Whenever can jump is active, it'll call the jump on stage routine, which is 2010. And whenever one of these don't actually exist, it goes to a common file, which all the AI share. So we can see 2040 right here. It doesn't exist in Ganon, but it exists here in the common folder. So this will be called instead. If it doesn't exist in the common folder, then there's probably something hard-coded in-game that it'll try and figure out. Video chance means like if the opponent is recovering and such, and so on and so forth. These are also the odds of this particular command, or being called, rather. So then we have the ATKD, or attack definition file, or attack dodge file, which basically tells other AI where the danger is in various moves. So, like, if Ganondorf is using attack 11, which is jab, or jab 1, the AI will want to start dodging at frame 7, and they'll want to stop dodging at frame 10. And they'll want to start dodging if they're like in between 2 and 7 and between 3 and 8 in the y-axis. These are the danger zone values. So if the AI is within this area and sees Ganondorf using jab, then between frames 7 and 10, they'll try to get out of the way. Now that we've covered the AIPD and ATKD files, it's time to actually look at these files right here, the .as files. These are the actual meat and potatoes of the AI, which give the AI the commands that are seen in the include folder. So let us look at one of Ganon's. Alright, so this appears to be the roll script, maybe? Figure out 0x70 from here. Roll base, yep. Okay, so Ganondorf in 70. So this is how the execution flow kind of works in these functions. It goes top to bottom. It's similar to assembly in that there are labels and jumps. There are no loops unless you actually make them with their own labels and jumps and stuff. So we have, if the distance from front edge is less than 25, it's going to finish the function. So it's going to return to the AIPD file and call something else. Otherwise, it's going to see this label and it's going to store that label in memory, which means it can come back to that label with return. So if the frame is greater or equal to 0 and the frame is not greater than or equal to 1, it's going to press X, I guess, for some reason. Oh, right. Okay. So the PMDT overwrote the roll script with a wave dash script. This is what controls that. So between frame 0 and 1, or just frame 0, the AI is going to jump. And then if the frame is 7 or more, the character is going to press R. And then the character is going to move the stick towards the player character, towards the target, and move the vertical stick, the stick in the Y direction, -1. So they're going to wave dash down. And once the frame is 10 or more, it's going to finish and then relinquish control back to the AIPD file. What does this return button, what does this return do then? Well, this returns execution to the game, right? And then on the next frame, it's going to continue from this label, which was stored in memory, and then go through this again. And so on and so forth for every frame until what appears to be frame 10. So there are various things that we can do here with the buttons. Instead of doing one button at a time, we can say button R plus A for shield plus attack, which gives you the grab input. What else can we do? Yes, there are jumps. And there are seeks. As well as, of course, the return and finish commands. So if I were to get rid of this, if I wanted to create my own roll function, so one thing of note here is that if you're going to call one script from another script with call, I don't know, jab 1, 2, 3. Yeah. You're always going to want 2 return statements at the bottom. Otherwise, it will crash for some reason. I'm not entirely sure why, but that's just how it works. So if I wanted to define my own role, I would just say like button R, wait a frame. So I'm going to say if num frames is greater than 2, or whatever, I'm going to move my stick in the direction away from the opponent. So stick. Oh wait, no, not oppost. We want to do away from the opponent. So it's going to take a var 0 equals oppost times -1. Oh, opponent's position means if they're on the left. Well, you can read this documentation here. Returns the position of the opponent. If the opponent is on the left side of the character, it's -1. Otherwise, they're on the right side, and that's going to be +1. And that just so happens to be how the control sticks work. So var 0 will be opponent's position, which is left or right, times -1, which will be opposite of the opponent's position. So var 0, 0, and we can finish. And then this is our very, 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 very basic roll away function. There are also things like, well, labels, as we said before. And we'll just name this label whatever. So labels are interesting in that if the execution flow naturally passes them, that is where the return statement on the next frame will leave off from. But there are ways to modify exactly which one is going to be jumped to. So if we say label whatever, right, it's going to jump to this, but then we're going to have my level 2. So my level 2 is now in memory as the next point to execute from. But if we want to execute from whatever, we can use seek. And then this will go up here, and this tells the game that on the next frame we want to seek from whatever. Alternatively, if we want, for whatever reason, to make a quick infinite loop, we can use the jump command. And jump is like return, except it happens instantly. So in the same frame, if we want to seek whatever, and then use the jump command, we will immediately go to whatever, then go back to my level 2 and seek whatever, jump, immediately go to whatever, and so on and so forth, creating an infinite loop that we don't want. However, these jump commands are actually useful. Let's put Cannon back to how he was. There we go. And you'll see that them used a lot in some of the pre-existing code. I forget exactly which one, but let's find out. 30D0, jump. Okay, let's find out what 30D0 is, shall we? So 30D0 corresponds to a command in the typical Project Plus game as 30D0, air dodge when attacked. When the AI sees the opponent attacking, and the AI is in the air, it has a chance of calling 30D0, which is air dodge when attacked. So we see this jump routine, yeah? So it sets a timeout for 15 frames. And if it's more than, which means if, for whatever reason, we go beyond 15 frames, the script is active for more than 15 frames, it is going to automatically call finish. Finish. And then var 0 is 100 minus the level value, which is the level of the character. This is not a linear scale, by the way. Level 5 is not 50. I have the values written down, but we'll get to that later. And we'll store var 0, 100 minus level value, and var 1. This appears to be the chance of actually air dodging, with level 9 being the, I guess, if I had to guess, then this is just the chance of them actually doing it. So with level 9 having the highest chance, and level 1 having the lowest, or no chance. So if they are not in the air, right, going to go to the list label. If they are not in the air, it's going to finish this. It's going to return control back to AIPD. If the opponent is attacking, and the distance to the opponent is less than 50 in any direction, it's going to set the timeout to 20, then seek this label here and jump to the label. So like it's going to immediately jump to the label in the same frame. Otherwise, it's just going to keep checking for up to 15 frames if the opponent is attacking and has a distance less than or equal to 50. So now this label fires, and now we have a timer of 20. If the frame is greater than or equal to var 0, anyway, if the frame is greater than or equal to var 0, whatever var 0 happens to be here, and the opponent in the character is falling, they're going to jump. So it looks like it's not air dodge when attacked, but the PMDT, or clean clipper, more likely, made it so that this script is now jump when attacked. So they're going to jump out of the way, and then finish, and give control back to AIPD. So that's what's happening here. So as you can see, like editing, reverse engineering, all that stuff with the AI used to be pretty darn tough. Remember, you couldn't even search the various files. Well, actually, no, you could. AScriptEd was really good for the time, but ever since Visual Studio Code came around, I have been spoiled by all the features like auto-completion and all the like nice features that I'm used to with other languages like TypeScript, JavaScript, etc. So what I did was like, I'm not about that. I do not want to spend all my time keeping track of the variables and what does what and etc. And while I'm on this topic, I really cannot give enough credit to King Clubber and Fifth CPU for actually delving in to this stuff, reverse engineering what it does, making notes, keeping track of everything way back in the day. And like Fox, you may hate it, you may hate the AI, but it is very, very impressive for 2013, 2014, 2015. Before the tools that I developed came around. What I did to remedy things, to make this process a lot easier for myself, so I'm not spending all that time just keeping track of the variables, as I said before, is I developed this preprocessor, this AI script pad editor extension, which allows me to actually do things like name variables, which is a very basic thing in other programming languages. You expect to have it, but here you only have a maximum of 24 variables at a time, var 0 through var 23, and they are all unnamed, but I decided to name them. So this preprocessor will look for anything like this pattern. So let's whatever equals var 2 or what have you, and it will replace all instances of whatever with var 2. And we can see that in action here actually. Let us go to equals 5. This won't be used at all, but I can demonstrate it. I also have consts, so I can name basic values and stuff. Magic number equals 42069 because I'm so hilarious. Just say whatever equals magic number. And now we can see these working together. And it makes for a much more maintainable experience. So what I'm going to do is right click on this folder, compile AI to the pack file, go into here, then see the output. And what this does is generate a pre-processed folder with the pre-processed variants of everything. Oh my. Oh, right. There's a lot of stuff here, but I'll get to why soon, TM. For now, though, we just are concerned with 30D0. Open the preprocessed version, and there we go. We see var2 equals 5 from whatever, and const magic number, whatever equals magic number, and here we have the magic number in question. So whatever equals 42069. And that gets compiled by Bero's code that actually keeps track of everything and converts it all into a language that the game can understand and puts it in this out file right here. Again, we'll get to why there are so many files here in a bit. That's some more tooling provided by my extension. You'll figure it out. Before I continue, I wanted to address something real quick. This unknown value is no longer unknown. That's just what it says with Bero's decompilation, because it wasn't known at the time what it does. And by reverse engineering with Ghidra, the NSA decompilation framework thing, we were able to figure out that this just tells the game exactly how many variables to set to 0. So this will set var 0 and 1 to 0, just to ensure that there's 0, to make sure that it's a baseline thing. This has become relatively obsolete. I don't like it, and so in my code I just set this to 0 or 0x0, and that allows me to have a consistent control over exactly what I am working with. So this true ID and stuff, this ID is the thing that actually determines what it is. So you can technically name the file anything, I think. I haven't actually tested it, but the ID is what will ultimately determine where things go. You might also see strings defined in various places. Let's see if we can find them. Ah, perfect. And we don't actually have all that much knowledge of what they actually do. So I just delete them and it seems to work. That's what I do in my code. You don't have to. Like, if you're working with some default AI, I recommend leaving them in, perhaps. Who knows? They might be important. What we hypothesize is they might point to some code in the game itself that actually executes and tells the AI what to do with some sort of very complicated routine. Another thing my extension allows me to do are use stuff aside from light and const, like macros. Macros are incredibly powerful. So I just paste it in the macro that I'm using elsewhere. What this does is nearest cliff. It takes 2 arguments, this macro. It takes an x var and a y var. And it executes, this is what gets inserted. So we use the get nearest cliff command, which not only stores the variable in the x var, but also the next variable over, so y var as well. Then it does some operations to make sure that this is relative to the character's current position. So if I wanted to do nearest cliff, let's near cliff x equals var 0. That's near cliff y equals var 1, and say near cliff y. Yep. This is how you would call upon the macro, and it will replace with this. And then I can do near cliff x. If we wanted to say move towards the nearest cliff, we can just do stick, just ending the script early, x. Stick can accept values that are beyond 1 or -1, and it'll just clamp them down to 1 or -1 if they're over. So if the cliff is to the left, it'll return a near cliff x will give you a negative value. If the cliff is on the right, it will return a positive value, and that actually, there we go. So absolute stick is like stick, except -1 is left, +1 is right. Whereas stick, if you do 1, it's just going to go forward, and -1 is backwards. Okay, so let's just go towards the nearest cliff. Stick near cliff x. I'm going to compile this.
going to go back into the pre-processed, find 30D0, and here it is. Get nearest cliff. 0 and abstick var 0, and voila. Okay, so near cliff X, or nearest cliff, that's cool and all. The macros, that's cool. Very powerful. We got let, const, the macros, very powerful, great. And the macros can be used in any file. But what if I told you it gets even more powerful? So there are now globals. If I wanted to, say, find a single let or give a name to a variable across all files, instead of naming it at the top of every file, I can simply do globals.as, and everything in here will be automatically shared across all these. So if I wanted to do let's something equals var 4, I guess, and then I wanted a const value, const max edge dist equals 50. Then we can say save this file, and then we can edit this to say if we're going to first take the absolute value, we're going to store something equals near cliff X abs something, which like takes the absolute value of something and puts it back into the something. If something is less than max is greater than max edge distance. If something is greater than max edge distance, then we want to get closer to the edge. So now, because we still have the near cliff X intact, we are going to abstick and near cliff X, and voila. Compiled successfully, great. We'll go over here, great. Abs var 4 equals var 0. Abs var 4, if var 4 is greater than 50, which comes from this, then abstick var 0. It looks very daunting when looking at it like this, but that's how the game needs to have it. But fortunately, we don't have to code like this. Again, we just code with the macros and stuff, and that converts all this into this. So you, again, might have been wondering why there are so many files in the pre-process section, or just these files. Well, I'll show you. Now we're going to start looking at my code. So we have AI Captain here, and this is all the files in his thing. And here are all the pre-processed files. There are quite a bit more. But the reason for them is because of, let me just close these, is because of the shared folder. So these allow you to share globals and macros across every single character that you compile. This also allows you to share code. So templates. So templates are basically the raw code that enables me to do a bunch of this stuff. So this template has an ID of 8000, 0x8000. Now if I were to add ID, this would completely override the shared thing, the shared template. But there is none that exist. Instead, you see these snippets and stuff. And what these snippets do, they're very similar to macros, except these snippets they don't take arguments, right? And they allow you to just insert the snippet wherever the snippet is defined in the template. I'm not sure if I have a basic example, unfortunately, but we can at least check here. So see prehooks here in the very top of the 0.as template. If I go into, I'm gonna go scanning. If I go into Captain Falcon, define this prehook snippet and give it like, and then I compile that to AI, which compiles successfully, great. Then in the 0.as file that gets compiled, we'll see it that it was inserted in that location. Same location right here in templates. So alongside the character snippets, there are these default snippets, which allow you to say, all right, if the character hasn't overridden the snippet or doesn't have a snippet of their own that's called like L-cancel or something, then just use what's defined here in this default snippets file. So I can just look at Captain Falcon. He does not have an L-cancel snippet. We can see in here that L-cancel is certainly a snippet that exists. So it just takes it from here, this shared snippet, and says, all right, here's the L-cancel, and puts it in here. All right, so the latest and greatest and perhaps most powerful feature of the AI script pad editing extension that I developed is the ability to use scripts. Scripts are defined in the shared folder alongside globals and macros. And they are JavaScript functions that you can run that directly run alongside the preprocessor. So the scripts are run, and then things are replaced, and then things are actually compiled. So I have this pick random move function here, jab102, which will pick and then return jab123, nair, F smash, and it's going to just directly call them in Captain Falcon's code. So I'm going to compile it real quick, and we can see here that we have the random move being output. We have var17 equals rand times 3. If var17 is less than 1, then just going to call jab123. If it's between 1 and 2, F smash between 2 and 3, nair. And it's going to randomly call one of these with thanks to this rand function. You call these scripts by using this $, followed by the script name, followed by the arguments that the script has. So pick random move, here's how it works in JavaScript. The scripts are all coded in JavaScript, by the way. That's the easiest way for me to implement it, and I don't really feel like implementing another language. So we export this, which allows us to actually use it in the code. Export const pick random move equals options, context, and then a function here. The possibilities are the options, and we split them by this character, this pipe character. Then we map them to this move named lowercase thing. We get the move list, and then we filter the move list. Then we output the random move. The output of the random move thing is just this. This is the code to create the string that is actually inserted in here. And I can actually use the preprocessor stuff, like the global names and etc. in here, because these then get preprocessed. We're just going to see what happens when I actually start up a match with Captain Falcon.
3,
Oh my goodness, what is that? Well, that is the debugger that I created. I created this with special C++ codes thanks to the incredible help and C++ framework by Fracture. You may have heard of him and his replay fixes and stuff. He is the reason why replays actually work now in Project Plus. So we have the selected script that the AI has, or the selected script that I have selected, the script that the AI is using, the AI mode, the AI inputs, the left stick and the right stick of the AI, and how long the current script was active for. If I press Z, R, and up on the D-pad,
1,
I can get more detail, and even more detail. Finally, we can see all the variables that the AI has at once here. So we see variables from 0 all the way through 23. We can see those change as the match goes on. So I'm just gonna let it go. And here we go. We can see every single variable at once. But that gets overwhelming fast and isn't always useful. Aside from that, I also have this down here. I have it logging some output to the console in Dolphin. You can get this by running Dolphin with -d and as a command line argument. And that allows me to see exactly when things have been changed. So let's see when he changes the script. So it's currently on 0059, and now it's on 8. Intermediate value is 0059, the current value is 0, and the next is 800. Yep, it's currently on 800, and it worked. So we get to see exactly how the scripts are changing. We can see how long things are for. We get to see the inputs, like this jump input that he's about to do, and we get to see the AI mode. On top of this, I have various things to debug combos. So currently the special mode is off, but if I press Z down to access them, and then Z left or right, we'll get the default script. So like regardless of what I have selected, the AI is going to be in the default mode. Like just process things in the regular way. And then a debug mode, which sets my damage to 0. But I can also fly now. This is very, very, very useful for testing like pathfinding and stuff with the AI. Check this out. When I get damaged, I actually go flying and stuff. And we can see that the number of hitstomp frames that are remaining, as well as the timer. And the timer is like additional frames on top of the hitstomp frames, just in case you don't want to immediately go back. So we have 24 frames of hit stun. Oh, he got me again. Will he get me again? Oh, he got me again. Alright, and now we're back. And I can adjust my damage as well. So if I press up or down on the D-pad, we'll get to see what happens with different damage values. So, up or down. Good job. This is my custom AI, by the way. It's working so far. I'll showcase the actual AI a little later, but okay. So for custom values, I have it set up so that Falcon, or actually anyone really, if I go to templates and 0.as, I'm treating 0.as as my AI hub of sorts. And I have this custom command that I have. I created this with C++ again, and it's a safe inject command. This allows me to set a value, then inject the value from the game. Check this out. So if I press Y and up on the D-pad, I get a custom value. And I have Y left or right, changes the custom value, which one it is. If I press A, up or down, I get to change the custom value by 1. A left and right, I get to change it by 0.05. So, with all these together, I'm able to say, we have this move selection, and based on which of these, whatever the custom value is, it's going to perform a different move. So let's make it use a forward tilt, for instance. It's going to be 3. So a custom value of 3, and then after he performs that, he's going to use forward tilts. Yep. Oop. Alright. Let's see what else we can make him do. We can make him use forward air, so 15. Or 14 rather. So yeah, that's the debugger. So here we are back in Captain Falcon. What I'm doing here is demonstrating some other custom commands that allow me to debug stuff even better. So I have this thing called log string and log val. Log val allows me to log a variable value. So say I wanted to log my opponent's position, or the AI's opponent's position, so top and X, then here I would use a preprocessor thing called string, file, top and Y. And then we can just track the position on each frame. So I'm going to compile this real quick. I'm going to go ahead and use this custom. I'm going to use VirtualBox to actually modify my SD card because for some reason, whatever people normally do doesn't work for me. So now that that's that, now that I have put the data in the SD card, it is time to go back and load this up.
Captain Falcon.
And then we should, if that works right, be able to see my position on the stage in the log window. So if I go over here, Final Destination or something,
3, 2, 1,
then you see on every frame my position. Now, right now it's 18.061, X 0.010, Y. If I go this way, it's going to increase in X position. If I jump, it's going to increase in Y position. And if I do both at once, I can do both at once. This is very, very useful for debugging various things that you might not be able to see or visualize. So, speaking of visualization, there is another thing that I have that actually does allow me to visualize stuff. So, if I wanted to draw a box at my position, this is another C++ code, and Fracture and I figured out how to draw boxes and various primitives to the screen. So, draw debug rect outline, going to draw it at top and X, top and Y. That's going to give this, we'll just give this a width of 5, height of 5, and a color, another preprocessor thing, of 0x. Let's make it red, so 880000, and make it partly transparent, 88. So remember this: red, green, blue, alpha. So then we can get rid of these logs. We're going to compile this again. And then we're going to go back to loading Captain Falcon.
Captain Falcon, Lucario.
With my character. And we're going to go to Final Destination, and we should, if I go straight there,
1,
see a box drawn at my feet. Yep, there it is. A red square. If we see, we can see it even better with Eon's amazing codes, the Hitbox Display and the stage collisions. So here we see the box at my feet, the top and Y bone, my character. It's going to be drawn like that every single frame, all thanks to the draw debug rect outline thing. What this also allows me to do is visualize extremely complicated operations. So I have this macro, right? And this macro is responsible for actually telling the game where, telling the AI where I am going to be. It is calc target distances. And I have some commented out stuff that's let's tell me about where I'm going to be here, as well as a whole bunch of stuff that visualizes my parameters for the hitbox and a bunch of other stuff. So you'll see in a second. I'll explain it. So we're going to compile this again.
3,
and check this out.
2, 1, go!
See all this stuff? So many boxes. But what do they mean? Well, I color coded stuff to so let's force them to use neutral air each time. Or forward air, rather. So for this, I'm visualizing where exactly the AI should go in target to hit their next attack. The blue is about, if I recall correctly, where I'm going to be. Oh, you got me. In the next, however many frames it takes for forwarder to come out. the green box is where Captain Falcon is trying. Well, like the green box is where Captain Falcon will try and attack if he is within. So let's see if we can make him use it. Huh, I'll have to fix that. But there we go. He's within the green box, and so he attacks. The yellow box is my character's height. And where exactly he's in it. The white box is the hitbox. So if I turn on Hitbox Display, you can actually see everything in action. So just do this. You can see Captain Falcon's hitbox for forward air right here. We can see my approximation of where that is. I had to code that in manually because there's sadly no easy way to automate that process as far as I'm aware. Yeah, this is effectively how I went about coding my character tracker for moves. Make him use a different move. Forward tilt. Sometimes it's just fun to watch him and see what happens. What are you doing, Falcon? Come on, you can do it. Oh, right. Okay, so sometimes the AI actually has to do some default pathfinding. That is a different AI mode. That is what you see with the AI MD thing. So check this out. If I go up here, they can't find a way. It's going to revert to a different AI mode after a while. I think. There we go. AI mode 6. That is his pathfinding routine. And then once it switches back to mode 2 or 1, those are the ones where we have control over. It's a very cool aesthetic, actually. I might record the next one in next showcase in this. I'll explain in more detail what these things do a little later. But that's for a different video. So yeah, you basically put everything together. All the pre-processing stuff, all the tools, all the abilities that the preprocessor and stuff gives you, and then you put it in the sd.raw, however your method of choice goes, and then you're able to play with it in game. So let us actually get rid of the drawing stuff, and then we can just see one of the results I'm proud of. Captain Falcon versus Mewtwo AI.
3, 2, 1, go! The winner is Red Team.